This time on KEI Fabrication.
Okay, so hopefully you can see this. What I've got is, this is the driver's side, this is the passenger side. The engine is offset to the driver's side because it turns left all the time. Alright folks, so let me explain. What you do for your grandkids, right?
Hurry up, we're gonna go all the way down.
Getting ready to go on another little reconnaissance mission.
Nice.
Hey folks, my name is Mike. This is KEI Fabrication and welcome to my shop. Hey folks, I just wanted to take a minute to thank you all for watching my videos. Thanks for subscribing. We're shooting to hit 1,000 subscribers before Christmas. So smash that like button, hit the subscribe button. We'd really appreciate it. We'd like to achieve that goal. so I've got the transmission mount bolted onto the transmission, and that'll be the target for the transmission crossmember. Hopefully you can see what's going on here. I've got a piece of 1/2 x square stock clamped to the frame to indicate, so I can get a measurement from where I want the tube to land on the frame to the fish mouth for the tube to engage the tubing that's going to go across. So this is going to have a slight dip down to reach down to the tranny mount, and that should allow the clearance for the shifter and all that other stuff. So I'm going to take some measurements, get a piece of tubing out, and put some bends in it, get it in position. Okay, so hopefully you can see this. What I've got is, this is the driver's side, this is the passenger side. The engine is offset to the driver's side because it turns left all the time. So I have a 45.5-inch overall and a 41-inch in between. I'm gonna make the bend longer in the lowered section, clearance for the shifter. Let's pretend these are the shifter levers. And I need to make sure that the top of the tube to the bottom of the frame has a drop of 1 1/8 inches. So what I'm going to do is I'm going to add 1 3/4 to this, so the top of the tube to the top of the tube is this measurement here. So basically 2 7/8. What I'm going to do is I'm going to cut a 48-inch chunk, and I'm going to come over and mark the 18-inch center line plus a little bit, and then I'm going to come over and mark my first bend start line and bend a certain amount, then mark my second bend start line, bend a certain amount, and then I will have I'll have basically a U, and then I'll flip it over in the die, and I will create a horizontal after I make the same degrees of bend on this side and the same degrees of bend on this side. Hopefully I'll get a nice drop tube cross member, and hopefully I'll be able to get this measurement after a couple of tries. So might be doing overkill here, but I'm really trying to make this tubular cross member go all the way through, because the walls of these frame rails is relatively thin. So again, it might be wishful thinking, but I'm going to do my best to try and pre-drill these holes so I can slip the cross member in and you know, feed it through, and then feed it back through the other side, and have a little bit of extra left over here to slide it back and forth, and then I can weld it here and weld it here, and through that process that'll help really prevent these rails from moving around when the chassis is trying to flex. Yeah, so the biggest reason is because of the thin wall tube of the frame rail itself. Trying to add some strength and structural integrity. So you'll see why I want to do this in terms of trying to strengthen up the frame, because I'm going to utilize this cross member as a landing point for some X bracing under the chassis. So let's see how I make out. bunch of stuff. Alright, let's talk a little bit about this bender. As embarrassing as it is for you folks to see this, I built this 30 years ago. And I went out and I bought a JD squared first generation bender, and I did all of my bends by hand with the ratcheting mechanism. Once I got into production of roll cage kits, I converted over to hydraulics, and I bought a motor from a friend of mine's, 220 volt, 2 horse. I believe the power steering pump is from, if I remember correctly, again we're talking 30 years ago, is from a 6-cylinder AMC that I picked up as a unit that I junked. The controls are from a forklift from a scrapyard, and the hydraulic piston is something that I bought at a swap meet. I have made thousands, and that's not an exaggeration, thousands of bends on this, and it's just my old reliable. So I need to clean it up real good. I need to clean the female die, I need to clean the pusher die up, and make sure that I'm not putting any scratches in the tubing when I bend it, so on and so forth. I don't think I've bent tubing with this particular bender in probably 8 or 9 years. I have a 1 5/8 bender, that's the next generation, that's on its own standalone setup with a foot pedal arrow of a hydraulic actuated piston. This particular bender has become my 1 3/4 diameter bender. It's just worked so well that I really have had no need to change it. I've done all kinds of improvements to it to make it quick. Again, this was my production bender for all of my NASCAR tubing. So, alright, let's plug this thing in and see if it works. Alright, now we just need to see if it still bends tubing. Alright folks, so this is the center line of the transmission. This is the distance I need from my bend start line on the driver's side to clear the shifting linkage. And this is the bend start line for the passenger side, which can be very, very close to the transmission mount because it's going to take a little bit of material before it starts turning up. One thing I want to try and enforce knowledge for you folks is if you're dealing with electric welded tubing, what you really want to do is make sure the welded seam, electric welded, is hot rolled electric welded tubing. So that means that there's a weld seam. You want to try to have it on the neutral axes of the bend, because as you'll see, the die is going to stretch material on this side and shrink it on this side. The neutral axis ends up being on the weld seam, so the amount of stress you're putting into the tubing and the highest stress point of this tubing, because it's been hardened as a result of the welding process, is the weld itself. You don't want to put all the stretch into that weld by having it on the outside or trying to have material move and shrink on the inside. So neutral axis. The weld seam should be on the neutral axis. So just because I know this bender for years and years and years, I've actually drilled a hole in this upper cross member of the bender to line up my bend start line. So just because I'm familiar with the bender, trying to guess where that is and trying to be repetitive in terms of production quality, I made sure that I was putting the bend start line in the same place all the time, and it helps to accurately position the bends as you need to make them. So this particular bender clamps on to the tube itself, and the tube remains stationary, and the shoe pushes around the die. Some benders, the tube stays still. Some benders, the tube moves along with the to create the bend. So anyway, here we go. I have no idea what I'm going to bend for the offset. I'm going to measure the length of stroke from the collar that holds the cylinder in place, and then I have a cut line on this clevis to measure the length of the bend. So here we go. Alright folks, there's the finished product. It took me a couple of tries. I went ahead and bent it what I thought was close, and then I did the offset and measured the drop, and then I matched it to the other side. Now I was shooting for 2 7/8. First of all, the alignment of this and this leg seems to be really, really good, and I'm shooting for 2 7/8 of a drop, and man, it's like within a 1/16, so if not right on. So I'm extremely happy. I really enjoy this part of fabrication. I really, really like bending tubing, and you know, this is what I'm really looking forward to getting into with this modified, is bending the roll cage and bending the Nerf bars and things like that, and then I really can't wait to get to the Mazda to do the full cage in that as well. So I'm going to see how this fits over here on the modified, try to figure out where the location of the holes will go through the frame, and see if I can get this thing to sneak into position. Alright folks, I tried to come up with the best method as I could to make sure that the measurements from the chassis to the center line of the transmission mount come into play, and I used straight edges and everything to mark it. I measured from reference points from both sides, so I'm going to climb in here and do the hole drilling through the frame with a hole saw. we got the cross member in, got the clearance for the shifter, got it tack welded in place, and the transmission and engine are now supported by its own mounts. The jack is lowered down, and what I'm going to do is I'll probably jimmy the cross member back out of there. It's not welded to the frame yet, it's just resting. And I will final weld with the transmission mount removed. It's tack, it's good heavy tack, so it shouldn't move around. Here's what it looks like from under the car. You can see it sticks out beyond the frame over here. I can weld it there, and this is the lift here. This is the bottom of the frame. You can see the bracket running across to the transmission polyurethane mount. Thanks again. Merry Christmas. Have a Happy New Year. Stay safe and healthy. And we look forward to working with all you folks next year.